Excellent. Well, welcome. Welcome to this training, Savio for Data Science Discovery. My name is Amy Neeser and I work in Research IT. And I want to just say a few words about Research IT and set a little bit of context for this training. So our department is actually located within the undergraduate education division on campus. So we're very, very excited to be partnering with CDSS in this way and really making research and computing and data technologies available to undergraduates for research. And we've been partnering with CDSS for quite a while in a number of different areas, starting with the Data Peers program, which is evolved, the Cloud Meetup, and many, many other ways as well. So just a few words about us and kind of what we do. We really, at the core of our work is that we partner with faculty, students, and staff to help with their data and their computation needs. And our goal is really to advance research on this campus. So we do that by helping researchers identify cloud computing, high performance computing, virtual machine solutions. And we also have a wide expertise in data security and data management to help researchers understand the sensitivity of their data as well as how to use and protect it. So we help them leverage these resources, which you'll learn much more about in this training, through our consulting program. And so some of our expert consultants are the ones presenting to you today about these resources that we believe will be a good help to you for your discovery projects. So with that, I will turn it over to these experts and please enjoy.
Hi, so I'm Clint. I'm one of the BRC domain consultants. I'm also a PhD student in the finance department, and I'm excited to introduce some of the resources we have available here at Berkeley for everyone. Before we talk about Savio, which is going to be the focus of this talk, I wanted to first mention another resource that might be available. It's just coming out of the sort of initial phases, but I've used it a lot for my own research, and so I'm excited to talk to you about it today. We're still figuring out the details as to how it might be offered. It's called AOD, which stands for Analytics Environment on Demand. Essentially, the service provides virtual machines for researchers and individuals who need to run analytic software packages like Python or R or RStudio in an environment that's scaled up from a standard laptop. And so I have access to an instance of AOD through the business school where I'm a student, and basically I have access to a computer that has a lot more RAM and a lot more computing power than even my fairly nice desktop computer. And so that allows me, for example, to load larger data sets. So the advantages of AOD are that it provides a familiar Windows environment, especially if you're a Windows user. You just can install your applications at the user level and go ahead with those. And it provides a graphical user interface for applications. And we're going to talk about how to access this on Savio later as well. But for example, if you're used to the Windows File Explorer, you're still able to use that when using AOD. One limitation of AOD, however, is that you can only access the resources on the AOD computer. There's a lot less flexibility in different types of resources. So for example, I don't think we have any access to GPUs via AOD. So there's more limited computing resources and flexibility of the resources. And if you were doing something very powerful that required multiple machines, AOD would not be a good fit. Accessing AOD is pretty simple. Basically, you first need to install the Citrix Workspace app. You don't need to log into the application after you install it. I've included the link here, so you just go and install the Workspace app. After that, you can go to citrix.berkeley.edu, and you simply log in with your usual CalNet credentials. At the bottom of the screen, you're going to want to select the Desktops option, and you should see the AOD desktop once you've been added. And once you click on that machine, it will trigger the download of a file. And when you open that file, it will open in the Citrix Workspace app, which you've installed. And basically, your desktop will just populate. Just one thing to note, if you just skip this first step and go to citrix.berkeley.edu, it may trigger you to install the Citrix, a different Citrix version, which is sort of outdated now. So I recommend really going and downloading the Citrix Workspace app before you jump to going to citrix.berkeley.edu. And so AOD is just going to look like a standard Windows desktop. I've included it here as a window, but you can make it full screen and it looks just like you're using a normal Windows computer, except for the fact you have this little black bar at the top once you've made it full screen, and that allows you to disconnect from the machine. I believe that it's worth noting that if you just disconnect from your AOD machine using the option that would be available from this black drop-down at the top, that would keep your machine running. So generally, when you're done using AOD, you're going to want to sign out. So hit the Windows button and then hit sign out. So next, and like I said, as the title of the presentation suggested, the focus of this talk is about Savio. And Savio is the UC Berkeley supercomputer. At a very high level, you can think of it as a lot of computing resources, nice desktops and GPUs that are networked together with a lot of fast storage. So we don't actually have desktops, we have sort of more stripped down computers essentially, or I'll use the term machines, that are divided into partitions. So these are groups of machines of similar types. So for example, the GPUs are in one partition. Computers that have a certain setup are in one partition. The newer computers are in a different partition. And so the current default is, for example, like Savio 3. And then the Savio 2 is sort of older machines. And the individual machines are typically referred to as nodes. So you can think of one node in the general sense, if you are unfamiliar with using a remote cluster, you can think of a node as basically like one desktop computer, functionally speaking. And with that, I will hand it over to my colleague Christian to take you through the next part of the talk.
I think that was a really robust overview of Savio, and now I will be talking a little bit more about Open OnDemand, which is another one of our platforms that you can use through Research IT. Yeah, so a little bit more about Open OnDemand. Open OnDemand is a web-based platform that takes a lot of the core functionalities that Savio carries and packs it into a really nice platform that comes with a built-in graphical user interface that is a lot more easier to navigate, especially for those that are not as familiar with command line terminals that you would usually find working with Savio. And so, yeah, this is a really great resource for people that are maybe a little bit newer to high performance computing clusters. And you're able to access all of the core functionalities that Savio gives you. And yeah, for advanced users, obviously it's a really great alternative that gives you a lot of convenient ways to access the functionalities that you're used to having. So just a brief overview of how Open OnDemand is structured, and this kind of gives you a little bit of insight into how Savio is the system architecture of Savio. Anyways, so like I said before, Open OnDemand is a web-based platform that basically allows you to connect directly to Savio through a really nice graphical user interface. And so it is connected to the Slurm scheduler that allows you to submit batch jobs and use different partitions and different different machines. And then it's also connected to the computing node. So like Clint mentioned before, the different partitions that you can think of as essentially as just a regular desktop app. It's connected directly to those, and then also it's connected to the file systems. So that's kind of the core functionalities of Savio: the file system, the computing, and then the Slurm scheduler. Next slide, please. Okay, so accessing and navigating Open OnDemand. So like I said before, Open OnDemand is a web-based platform. So the first thing that you would want to do is go to this link, which is up at the top, ood.brc.berkeley.edu. And just a recommendation, you would probably want to use a Chrome or Firefox to access this link. Safari has been known to have some authentication issues in the past. But yeah, you would go to this link, and once you pull this up, then it would pull up this little box right here that would ask you for your username and your password. And so your username would be your BRC username that you would get when you form your account. And then your password is going to be your PIN, which is going to be 4 digits, as well as the one-time password from your Google Authenticator. And so once you type all of that in, then it would give you access to the main page. So next slide, please. So yeah, once you have successfully logged in, then you will see a page that looks something like this. This will be the main page where up at the top, you have files, which gives you access to the file system, which I'll talk a little bit more about in a minute. Your jobs, where you can view jobs that have been submitted and track their progress. Clusters, interactive apps. This is where you're going to have access to Jupyter, Jupyter Lab, RStudio, MATLAB, and all of the other interactive apps that we'll talk a bit about in a second. And then you can also manage your interactive sessions that you have open. And so, yeah, this is going to be the homepage that you will use in order to access all the other functions that you want to get to. So next slide, please. Okay, so for managing files, Open OnDemand has direct access to Savio's file system. And so if you want to access the files that are in either your home or Scratch directory, which I'll talk a bit about in a second, you would click on the Files tab. And this is where you can view and edit your files. You can create, rename, move files to different directories. And you can also upload and download files from your personal device to Savio's file systems. Just to note that this is better for kind of smaller files. If you need to move larger files, we have a different system called Globus, which is specifically designed for the transfer of kind of larger files. And so we'll provide some resources around Globus if any of you have interest or a need to use that. So next slide, please. Yeah, and this is kind of an overview of what your main file system is going to look like. So over on the left, this is the home directory. So this is all of the files that you would have in your home directory. And then at the top, you see that you can view individual files, edit them, rename them. Excuse me, you can download them to your personal device, copy, yeah, and yeah, and then you can also create files, upload files from your personal device. And when you open a file, this is what it is going to look like over here on the right. And just to note that whenever you are finished editing a file, you want to hit save and not Control S, because that will not work. So yeah, next slide, please. Yeah, okay, so this space options. So like I mentioned before, the way that Savio's file systems are set up, you have a home directory and a Scratch directory. So for your home directory, that will come with 10 gigabytes of backed up storage. And so this is where you would want to store any software that you might need to use, files that are important for whatever computations that you're running. But just keep in mind that 10 gigabytes is definitely not a lot. So you want to just consider that whenever you're having to move data or store data in different places. Your Scratch directory is The other option outside of your home directory, it comes with a lot more storage. However, it's not backed up. And so, yeah, you definitely just need to keep that in mind whenever you're moving files around. And from a computation standpoint, you want to run most of your computations from your Scratch directory because this is connected via InfiniBand. And home directory is only connected via Ethernet. And so it's the connection between Scratch and the rest of the computing nodes is much faster. And yeah, next slide, please. Yeah, and so for most uses, yeah, you want to put your data in your Scratch directory. And like I said before, this is where you would want to do most of your computations because the connection, it's connected directly to the computing nodes. And if you are trying to do computations in your home directory, for example, because that connection is not as robust, that could potentially cause issues for other users and can significantly slow down the entire system. So yeah, just keep that in mind whenever you're moving files around and doing what you need to do. So yeah, next slide, please. Yeah, and for those that are comfortable working in a command line terminal, you do also have the option to pull up a terminal directly in Open OnDemand. So you just go to the main page that I mentioned before, and you go up to clusters, and then you would click on one of the tabs where it says shell access, and then this would pull up a command line terminal where you can work if you are comfortable in that environment. And yeah, then I think I will hand it over to my colleague, Alex, who will take over for accessing the Jupyter server and computing.
Yeah, Clint, would you mind just continuing that screen share? Awesome. End slide. Cool. So I think probably the best way to interact with Savio via Open OnDemand is through Jupyter Notebooks. It's an environment that I think most of you are probably already pretty familiar with, and it gives you access to pretty much all of the resources of Savio through a really nice, clean Jupyter Notebooks interface, just like Data Hub would, but with more computational resources behind it. And so basically all you need to do to start a Jupyter notebook running on Savio is click on that interactive apps option in Open OnDemand, set up a node to compute on by sort of specifying your partition, and then you'll have a Jupyter server ready to run. Slide, please. So if you just want to test a quick app, you could use the debug partition, which will let you basically spin up a server really quick without much computational power behind it. So you won't want to use this to like train a model or something, but if you're just testing something really quick, like you might on Data Hub, then this is a good option. That wall clock time basically tells Savio how long you want your Jupyter notebook to run for. So a wall clock time of 1 is 1 hour, 2 is 2 hours, and you can sort of set that to run for however long you need it to run for. Next slide, please. So kind of the way we specify how many resources we want Savio to give our notebooks is via a system called Slurm. And you don't need to know sort of all of the details of how Slurm works. But essentially what it's doing is saying, okay, we need these kinds of resources. So earlier we mentioned that Savio is composed of nodes, sort of individual computers that you can essentially rent time on. Now we have a couple different kinds of nodes. For instance, Savio 1, Savio 2, and Savio 3, sort of in an increasing order of newness and power. So if I want one of the latest Savio 3 nodes, I would just select my Slurm partition as Savio 3. I can put in my account name, which is basically sort of what I'm billing the resources to, and Data Science Discovery would give you one of these accounts. And then I'm essentially just saying, I want those resources. So, Savio normal on Savio 3, which is going to give me a lot of RAM and a really powerful CPU for a certain amount of time, so say 1 hour. And then just like with a debug partition, I can get that up and running. Slide. So once that's started up, you'll see this screen, sort of it'll go green, and then you're ready to log into your Jupyter Notebook. Slide, please. So then you'll get this clean Jupyter interface, sort of just like you would see in Data Hub, and it'll be really easy to kind of do the exact same thing you would on Data Hub or in your local environment. It works the exact same way. Slide, please. And if you prefer sort of the Jupyter Lab interface, you can just replace the tree with lab. Slide, please. So you also have a couple options if you don't want to just use Python. You can actually build a custom kernel using a different language like Julia or R. Or if you want to use a conda environment, you can create sort of a custom Python kernel with the exact versions of the packages and software that you need. Slide, please. So one of the tools we recommend using is Conda for your dependency management. It can get pretty complicated if you have to wrangle a bunch of different versions of Python and common packages like scikit-learn or NumPy. And so what you can do is create a Conda environment. Now, these Conda environments get pretty big, so we recommend putting those in your Scratch directory, which is kind of, for our purposes, basically an unlimited place to store files compared to your home directory, which is backed up, but you only get 10 gigabytes of storage. Now, if you're downloading a lot of Python packages, you'll probably exceed that 10 gigabyte limit, especially if you're doing sort of machine learning, like with PyTorch. And so we recommend using the Scratch directory to store your Conda environments in. So once you create a Conda environment, you can use that in your Jupyter Notebooks. So you have access to the right versions of packages and the right versions of Python, not just whatever's kind of on by default. Slide, please. And so once you're finished running your experiments or processing your jobs, all you have to do is click delete. It'll remove that Jupyter Notebook. You can log out of the portal, and it's going to clean everything up for you. Storing whatever data you need in your home directory or Scratch. And then when you're ready to run another job, you can just come back and start up a new notebook. Slide, please. So there's a couple other interactive apps we have available for you to use on Savio beyond just Jupyter Notebooks. One of those is RStudio Server. So if you're an R user, you're not just limited to Jupyter Notebooks. We also have essentially a full version of RStudio you can run on one of these more powerful nodes instead of running it on your local system. Slide, please. We also have a VS Code server, so you can have sort of an integrated IDE running on Savio. So again, more power than your local system. And slide. And kind of the other way to access Savio is via our Linux desktop. So if you need to run something with a graphical user interface, you can basically get a full Linux desktop running on one of the Savio nodes. And last but not least, slide, you can access Savio through the shell. And so this is really useful if you need to do something you can't really do just through sort of the standard features we have available on Open OnDemand. And it's useful for submitting more advanced jobs. Slide, please. So for instance, if you're submitting a batch job, so something you need to, say, run for multiple days or overnight, or you don't want to do it through a platform like RStudio or Jupyter Notebooks, you can actually submit jobs through the command line. And so we have more info on this in our documentation and some example scripts for you to run, but essentially it's the same thing we did earlier when we asked for a Jupyter Notebook. You're kind of just going and saying, hey, I need these resources and I want to run this script on this type of node, and then our system will take that and go out and run it for you. And last but not least, we sort of have a couple more resources for you to think about as you're looking to work further on Savio. So if you have sensitive data, you can't just store that on Savio. There's certain protections you need to take based on the security level of your data. So especially if you're dealing with things like healthcare data or human subjects, some of that data might be protected under the UC data privacy guidelines. And so if you have that kind of data, I would recommend reaching out to us so we can discuss your options for where to store it. Savio does have ways to support level P2 and P3 data, but it has to be kept in a separate place. And then we also have a compute platform for the most highly secure data, P4 data. But you do need a separate onboarding process for that. So kind of let us know if you have that kind of data and we can help you process it. Slide. And then here's a couple of really useful links that you can find in the slide deck after we finish this presentation, sort of to our documentation, which you can find at docs-research-it.berkeley.edu. This kind of takes you through all the stuff we just talked about with Open OnDemand, with Savio, with Slurm, and how to use all of these resources. And finally, if you need additional help, we have office hours twice a week that you can come to and kind of talk to one of the consultants. You can email us about Savio or really sort of any computationally related research questions, and we can sort of help direct you to the right resources on campus. And if you have issues with sort of your research data, whether that's security or where to store it, we can also assist with that. Yeah. So I think that kind of opens us up to if there's any questions.
Because we've got time for the Q&A. So this will only cover a small fraction of what Alex talked about. And so first of all, let me share the screen. I'm going to show you just how to swap in a Jupyter Notebook on Savio and a Jupyter Notebook on Savio. And if you take a look, the most challenging thing for any of these systems, at least for me, is always logging in. So here you can see I've gone to ood.brc.berkeley.edu, and this pulls up a login screen. And one of the things I'm going to do is I'm going to type in first my PIN, which should be like your ATM PIN, something for you to remember. And I hope people can see this. I'm using Google Authenticator. I've set up an account on it, and it's generating me a one-time password, which I'm going to type in. Whoops. Now I've lost the screen, which I'm going to type in following that. So your password is 10 digits. 4 digits, which is your persistent whoops. And then 6 digits, which is the one-time password that that is generated. So download the Google Authenticator app. As you walk through the I haven't demoed this, but as you walk through the pages on Savio, it will show you how to create an account on Savio and how to set this up so that you can get your one-time password on your phone. So now I'm logged in as McGear, and now what I want to do is go to Interactive Apps, Jupyter Server, and I'm going to just do a compute on shared Jupyter Notebook for exploration and debugging very quickly. So I want 3.7. The name of the job is OOD Jupyter, and I want this for 1 hour. I'll just go ahead and launch it. And now it will take a few minutes for it to swap in. And while about a minute, oops, it's already swapped in. Well, wait a minute. It takes a few minutes, so this is a good time for people to ask questions, which is why I wanted to get this started now. So please go ahead. Any questions? Primarily for Alex and Clint. So here we go. I'll connect to Jupyter. And when I do, as you can see, we just get the standard Jupyter interface. And to turn this into a lab session, I just type in lab here. Whoops. Pardon me. I just type lab here. And that gives me that gives me the lab session. And what you'll see with Jupyter Lab is that here I have my home directory. This is my standard. This is my standard home directory, not the scratch directory, which is in /global/. As you can see, in addition, we have the usual launcher with a broad variety of environments that are available. A small directory here, and of course that most useful of all applications, the Linux desktop. And as you can see, I have about 3.1 meg in my personal directory. And if I wanted to do, I was going to show a quick demo of how to do analytics, but you've all done this in data science. So it's just a standard notebook environment that you've all seen before. And with that, that's the end of the demo. There is a longer version on YouTube, and I'll put the link in the chat. Or I set this up and use VI from my Linux terminal in order to do some cleansing of the CIS.csv dataset that I downloaded from Kaggle.
Fantastic. Thank you. Thank you, everyone. Thank you very much. I'm going to stop the recording now.